Hello student, today I am going to discuss you one topic, that is convex hull. First of all, what is convex hull? Convex hull is the smallest polygon that covers a certain set of points. So to understand it, I am taking some points. Suppose these are points P1, P2, P3, P4, P5, P6, P7. Then the smallest polygon, formed by with smallest area, which covers all the points either inside it or on the boundary, is called the convex hull. So the set so the smallest polygon with minimum area possible, minimum area which contains all the points either inside side or on the or on its boundary is called convex hull. Right? So, as for example, here there are total 6 points, and this is the polygon that is formed by the connecting these points. Either all the points are within this polygon or on the boundary of this polygon. That is called the smallest polygon. So this is used in number of places, like for stars we cover all these stars into certain shape, and we call them that this is the galaxy. We collect all the spatial objects which are dense in a dense region. We classify it as a galaxy, or then similarly these are a lot of field in which we find out the region in which the location of certain point is very high, and to distinguish that point from the other portion. So how do we find the convex hull for the given set of points? For this there are two algorithms. One is Graham's algorithm and second one is Jarvis algorithm. So today I am going to discuss you the Graham's algorithm. So first, to understand that, I am going to write the algorithm, then I shall take an example, and with that example it would be clear to you that how do we construct the convex hull. Right. Huh? Okay. In case of die, take the second. count P0. Same angle. Take the farthest one. Right. Third point. Okay, so first of all, this is taking a large space. So rest of the part I shall write after rubbing this one. First of all, I shall discuss these points, and this algorithm is very simple. The logic can be expressed in one or two lines, but initially we have to define our references. First of all, out of the, suppose there is a separate set of points Q, out of which we are selecting a point which is having the least y coordinate, means that the point that is having the least y coordinate is selected one. If suppose there are more than one points which are having the least y coordinate, then we select the one which is the leftmost one, or we compare the least yx coordinate. Okay, first of all, we out of the collection of the points, we find out the points which are having the minimum y coordinates. If more than one points are having the same value of y coordinates, then we select in between these points the one which is leftmost point, or which is having the least x coordinate. After that, what we do, after doing this, we mark that point as P0. After marking the point P0, which is having the minimum y coordinates, and in case of tie is the leftmost point, we set the order of the other points in the set. How do we set this? For this, we take the reference of the polar angle. Polar angle in anti-clockwise direction. First of all, with increasing angle, we keep mark the point P1, P2, P3 up to Pn. It means every point is assigned an order P1, P2, P4, P5 depending upon the increasing order. For example, there are 3 points. Suppose this is the point P0 and there are 3 points. This point is having the least angle, then this would be the P1. This point with reference to the x-axis. This point is having the least angle, so this will be marked as P1. The next point is having the greater angle, so this will be the P2, and this angle will have the value P3, and so on. It means like this we shall give a certain index to every point with reference to the point P0 in anti-clockwise direction with increasing angle, polar angle. As the point with the minimum polar angle will have the value P1, then P2, then P3 up to Pn. It means we have identified the point P0, we have assigned we have indexed all the all the points in the data sets with value P1, P2, P3, which mark the increasing polar angle with respect to point P0. After that, we initialize a stack. In this stack, which starts with empty state, we insert 3 elements, 3 consecutive elements P0, P1 and PS. Here all these operations are push operation, means the first 3 points P1, P0, P1, P2 will be inserted inside the stack. The next steps I am going to write after rubbing this page. So after point 6, rest of the point I am writing. Eighth point. Uh, for I is equals to 3 to m, where m is the number of the points, 9, points next to top S, top S and P I makes uh, makes an anti-clockwise turn. Then do pop S, and ninth, push and push SPI, and then return S. Here these points can be defined that we have what we have done in the last steps. We have initialized, identified the point P0, the point with the minimum Y index, and we have marked rest of the point as P0, P1, P2, P3 up with increasing polar angle. After that, we initialized an stack with an empty stack in which we inserted uh, 3 points where the first point P0, P1, P2, like this. When we insert 3 points, then we check out what is the rotation of the edge from P0, P1 to P1, P2. For I am repeating it once again. There are points P0, P1, and suppose this point is P2. Then we shall check out whether the angle of movement from P0, P1 to P1, P2 is anti-clockwise or clockwise. If this angle is clockwise, then what we do, we push the new element. And if the angle is anti-clockwise, then what we do, we pop the element. Here it is written that if do I for rest of the element, for we initially we insert the first three element, which P0, P1, P2. After that, for the from the third element to the last element, what we do, we check out that if the what is the angle formed by the element on the top of the stack, the element below the top of the stack, and the element that is next one. The angle formed in between this, if it is anti-clockwise turn, then we pop the topmost element of the stack. Otherwise, we push the next element into the stack. I repeat it. If the angle is anti-clockwise, then we pop the or we out make the top pop the top element. And if they are making a clockwise turn, then we push the next element into the stack. So we keep on doing the process, and at the end we get the final convex hull. So after to make it more clear, I am going to take one example, and with help of which it would be more clear to you. Suppose here I am taking a points. These are the points. Okay. right? These are the points. Among these points, we shall find out the, first of all, I have marked these points like this, right? I shall identify that these are the points which can be the with the minimum y coordinates, but in case of tie, we shall select the points with the minimum y coordinates. So we'll select this point and we shall mark this as P0. And now we shall mark the rest of the angle in order of their increasing polar angle. And if there are more than one points at the same angle, then we select the farthest one. So I shall draw the line P1. This will be the P1, and this point P2, P3, P4. Here in this case, two angles are at the same position. There are 2 points which are at the same angle, so we shall select the farthest one. Means this one will mark as P5. Right? After that, P6 and P7, P6, P7, and here P8, and this one is P9 and P10, P11, and finally P12 and P13. Right? We have marked all the points. Okay, this point is P12 and this is, so the first step is to assign a value to each point and remove the points which are on the same angle and select only one which is the farthest one. So I am going to rub all these, I have assigned all the angles. So to make it clear, I am going to rub these dotted lines so that the picture becomes clear to you. These dot points have only significance that they were used to assign the index to these points, right? So P6, I am going to delete P6 and rest of the element will be deleted as P6. Now there, at one angle there would be only one point. So this will be the P6, this would be the P7, and this one as P8. Because at one angle, I am highlighting these points, right? This one, this one. Okay. Now, what we shall do here? First, I shall draw a line in start and stack, and S with 3 elements P0, P1, and P2. Here, P0 and P1, P2. It is a clockwise direction. When it is a clockwise direction, what we do? We push the second element. So the next element is P3. So we shall insert the element P3 inside this one, P0, P1, and P2, and the next element is P3. But at this position, we shall check, sorry, P2. Now we shall check what is the angle formation between P0, P1, P2 and P3. It is a clockwise direction. When it is a clockwise direction, then we push the next element. So the element would be inserted into it, right? Now the next one element is P4. Again, this is a clockwise direction. So the next step element would be the P0, P1, P2, P3 and P4, right? Here this it was again a between P2 P3 and P3 P4 the angle is clockwise direction, because from that, as we shall consider the smallest angle, somebody may suppose that we can move from this side to this side also, but between the two direction we select the angle which one is smaller. So in this direction, when we move from this direction, this angle is smaller than, and this is the clockwise direction, so we push the next element. Now from here P4 to P5, the angle is anti-clockwise. The angle is anti-clockwise, and we will try to push P5. In that case, we shall remove this element, pop the top element P4. So after this, the stack would become like this: P0, P1, P2, P3, right? P0, P1, P2, P3, right? Now we have popped P4 because the angle formation between P3, P4 and P4, P5 is anti-clockwise. So we have popped that element. Now after this, we shall take the next element. We can't connect to the other element directly. We shall follow the index. So between P5 and P6, the angle formation between as P4 has been popped from the stack. So we shall find out the angle between the P3, P5, and because 3 is the next element, top element, P3, P5 and P6. Take care that when you have popped an element, you will not consider that element. So this element is P3, P5 and P6. So we shall check out that what is the angle formation. This is the clockwise direction. So we shall pop the element P6 into the P5 into the stack. We have popped the element, and the angle formation between the last element was P2, P3 and P5. First of all, I have jumped a step. P2, P3 and P3, P5. P3, P5, the angle formation is between P2, P3 and P3, P5. The angle formation is clockwise. So we shall insert the stack the element P5, P0, P1, P2, P3 and P5, right? And now because the angle between this, so we shall eliminate these two edges because this element has been popped, so this will not exist anymore. So we shall mark this angle, right? Only P3, P5, right? Now we shall consider the next point. The angle formation between P3, P5 and P6 is also a clockwise direction. So we shall insert the next element P0, P1, P2, P3, P5 and P6, right? Because here the angle between these P3, P5 and P5, P6 is clockwise, so we shall insert that element. After this, the angle formation between P5, P6 and P7 is anti-clockwise. P5, P6 and P6, P7 is anti-clockwise. So in that case, we shall pop the top element. So we shall remove the pop element. So after this, it will appear like that: P0, P1, P2, P3, P5, right? And this is the so P5 will be popped out of the stack. Now the next element would be P6 has been deleted. So now we shall delete the corresponding edge also. Right? Now we shall check out. I am marking this edge by dotted line because this has been eliminated. Right? Similarly, these lines are marked. I shall mark the deleted line by dotted line. Right? Now we shall check the point between next to top element and the next element next to top element. So this point, this is angle formation is clockwise direction. So we shall insert the next element P7. So next element P7 inside the stack, right? Now we have inserted the P7 element because the angle between P3, P5 and P5, P7 is clockwise direction, right? Now after this we shall check that, and next for the next element P5, P7 and P7, P8, the angle is anti-clockwise. Angle is anti-clockwise, so we shall push the of the element P7. P5 and next element is P8, right? P7 will be popped out, and as this element has been removed from the stack, so these lines will be marked by the dotted line, and we shall form the edge this one, right? Okay, now we shall check the next point in the series, that is P10. The angle formation between the P5, P8 and P10 is clockwise direction. So the next element would be inserted P0, P1, P2, P3, P5, P8 and P10, right? Then now the next element in the series will have a clockwise direction, so we shall insert the next element P11 also, right? That because this angle formation is also clockwise, it is near about 178, 179 degree, but this side is a smaller one, so we shall consider as clockwise. The next point is also a clockwise direction, so we shall insert the next element also into the stack. P0, P1, P2, P3, P5, P8, P10, P11 and P12, right? We have inserted the element. Now next movement, that is the angle between P12 and P13 is anti-clockwise. So we shall remove the top element 12 from the stack, and we shall insert from the element, and after removing the stack would remove this, and the next element we shall check the angle formation between, so we shall remove, so I am rubbing here this part, starting it from here. So after the 12 will be removed from the stack, the element are P0, P1, P2, P3, P5, P8, P10, P8, P10 and P10 and P11. Because 12 has been removed, this element has been popped 12, because this angle formation is anti-clockwise. Now again we shall delete this edge and mark this by dotted line. This will be a dot, because 12 has been removed, so this will be a dotted line. So again we shall find out between the edge between P10, P11, P10, P11 and P13. Again this angle is a anti-clockwise direction. So again we shall remove the element P11 from the stack. So the stack would become like this: P0, P1, P2, P3, P5, P8, P10, right? Because 11 has been removed, so we shall again mark this by dotted line. Right? And we shall check the angle formation between P10 and P13. But here also the angle formation is in anti-clockwise direction. So again P10 will be removed from this stack. So we are left with the element P0, P1, P2, P3, P5 and P8. Now we shall remove this element also. So this would be marked by dotted line. Right? Now we shall check the angle formation between P5, P8 and P13. And this angle is a clockwise direction. So we shall insert the element P13 into the stack on the top of the stack. At this point, this is the clockwise direction. So we shall insert the P13 inside on the top of the stack. After that, the next point is we shall reconnect. No other point is left, so we shall connect the last point with the initial point and we shall check the angle, and this formation is clockwise, so this will be the final set of the convex hull. So after removing the dotted line, what we have got, we shall remove all the points which are not connected. Here I have marked the eliminated point by the dotted line, but these points will not exist after the removal from the stack. So by deleting all these points, I am highlighting the convex hull by double line. So this will be the final convex hull highlighted by the double edge boundary, and these points will be the these points, I am deleting the rest of the points. So this will be the final convex hull, right? And the final complexity of it would be equals to final complexity of this will be n log n will be equals to n log n. This is convex hull is the smallest polygon that cover all the points either inside it or on the boundary of it. So this is the method of the convex hull. That's all. Thank you.